Welcome everyone. Today we are presenting our study Laughing Out Loud, Exploring AI-generated and human-generated humor. This work conducted by our team at DZHW, German Center of Higher Education and Research Study, delves into the nuances of humor generation by AI and compares it with human capabilities in this domain. My name is Parisa Safikhani, and together with my colleague Hayastan Avetisyan, I will present this work. I'll begin with an introduction, followed by a discussion of recent works in this field. I'll then outline our experiments and delve into the results. After that, my colleague will take over to present the linguistic analysis part of our work aligned with our key findings and conclusion. Finally, she will discuss our project's limitation and future directions. We conducted a comparative analysis of AI-generated humor against what we traditionally consider funny, human-generated humor. Our aim is to investigate and understand the composition of humor created by AI. Our objectives are twofold. First, we seek to unravel the capabilities of AI in crafting humorous content. Can a machine learn to be funny? And whether the machine can recognize between human or AI-generated contents. And secondly, we want to evaluate this content critically for its funniness and originality. These are the benchmarks that will help us measure AI progress in this creative domain. Now let's look at some of the key studies that set the stage for our research. Prajapati and colleagues pioneered the comparison of machine learning and deep learning in humor detection. They sifted through tweets, categorizing them as humorous or not. Their finding, deep learning outshone traditional methods, offering superior accuracy in predicting humor. Kumarwala and Sharma took it a step further. They introduced an innovative humor detection technique that marries convolutional neural networks and long short-term memory layers. Moving on, Matthias Marcello's work is classifying humor, and offensive speech brings another dimension to our understanding. By employing machine learning models, particularly those based on BERT, they offered insights into the nuanced performance of these models in detecting humor interviewed with offense. Lastly, excuse me. Lastly, we have Haloniast, who conducted a comprehensive review of computational humor recognition. Their work stands as a meta-analysis considering various papers, datasets, features, and algorithms. First, we have the AI-generated dataset. We use ChatGPT, specifically its GPT-4 model, to create a dataset for humor detection. This dataset includes 500 entries, both humorous and non-humorous. Due to ChatGPT's limitation in generating large number of entries at once, we prompted the model every 20 entries to continue the generation process. However, we encountered a challenge: significant duplicates in the humorous section. To achieve a balanced duplicate-free dataset, we ultimately prompted ChatGPT 970 times. Turning to the human-generated dataset, we utilized the well-known Colbert dataset. This dataset, originally comprising 200,000 entries, was used to examine BERT sentence embedding in humor detection. To align with the AI-generated dataset, we randomly reduced it to 500 entries, ensuring the balance of humorous and non-humorous content was maintained. Our test set has been carefully curated. The human-generated test set consists of 100 entries selected from Colbert's content. They were selected to represent a wide range of Colbert's speech patterns, ensuring that there was no overlap with the training set. For the AI-generated test set, we utilized the Bing chatbot, employing prompting methodology similar to that of ChatGPT. The Bing chatbot was the ideal choice for testing the generalizability of our model. Experiment 1. We fine-tuned the Roberta model twice, once with a human-generated humor detection dataset and once with an AI-generated dataset. We set specific learning parameters and used the Adam optimizer. Our primary goal was to evaluate the performance of the model for the same type of humor for which it was trained. Then we aimed to see if Roberta could differentiate whether texts, humorous or not, were generated by humans or AI. We used a mixed data set of AI and human text, each labeled accordingly, and tested the model's ability to identify this code. Experiment 3 exclusively focused on humorous content, discarding all non-humorous text. We then replicated the second experiment in this narrowed context to evaluate whether the model was more adept at differentiating between humor generated by humans and that generated by AI. As already mentioned, our first experiment focused on the Roberta model, fine-tuned on datasets for humor detection. Once a human-generated dataset and once an AI-generated dataset. Yeah. Remarkably, the model achieved perfect F1 score for both human and AI-generated content on the test set. Interestingly, the model trained on AI-generated humor reached this level of accuracy in just 2 epochs, compared to 4 epochs for the human-generated content. This suggests that human-generated humor is more complex than its AI-generated contents. Moving to our second experiment, we tested the model on a mixture of data generated by humans and Bing chatbot. The model continued to show excellent performance, achieving an F1 score of 100% within 4 epochs. This proves that it is able to accurately classify the origin of the text regardless of the presence of humor. To test the model's generalizability, we applied it to the extensive Colbert dataset. The model accurately classified the entire dataset as human-generated, achieving a 98% accuracy rate. This underscores the potential of using a small, diverse dataset to construct a model capable of efficiently categorizing large-scale data. In our third experiment, we focused solely on humorous contents. The model achieved an F1 score of 97.99% within 2 epochs. The result showed a slight decrease in accuracy compared to the mixed data, indicating the complexity of humor content. Now I'll hand over to my colleague, who will continue with the linguistic analysis and further insights from our work.
So we took a methodical approach to annotating texts, assessing them on the scales of funniness and originality. Our methodology involved 2 evaluators whose assessments were conducted blind to the source of the text, ensuring that their judgments were not influenced by knowing whether the humor was crafted by AI or humans. The funniness rating ranged from 1 for not funny at all to 5 for hilarious. In terms of originality, texts were rated from 1 for not original to 5 for highly original. These scales allowed our evaluators to provide nuanced feedback on each text. To maintain the consistency and objectivity of our data, evaluators followed strict guidelines. Any differences in ratings were carefully resolved through discussion or, if necessary, by consulting a third evaluator. This process ensured that our dataset was accurately annotated, allowing us to draw meaningful comparisons between the humor produced by humans and AI. Right, now we will dwell on the analysis of our dataset. Let's begin with bigrams. Our analysis revealed a fascinating intersection. The top 10 bigrams showed substantial overlap between AI and human humor. Terms like do you, what do, and the classic knock knock feature prominently. The similarity in language structures lays the groundwork for deeper analysis into the mechanism of humor. As for the sentiment, AI tends to stick to a more neutral tone, while human humor lies across a broader spectrum of sentiment. Despite this, the majority of sentiment in both datasets tends to be neutral, which is a very interesting finding that invites further inquiry. Diving into the grammar, we note that certain parts of speech, such as nouns, punctuations, pronouns, and verbs, are commonly used tags in both AI and human jokes. This observation suggests that AI is reflecting human syntactic structure, but nuances remain, therefore, more studies are needed. In terms of brevity, AI tends to be more concise, with an average of 12 words per humorous snippet, compared to humans who average at 14 words. This brevity could imply that AI-generated humor is more to the point, or perhaps that it captures the essence of a joke just in fewer words. In sum, our exploration into the linguistic patterns of AI and human humor has revealed important insights. It provides a gateway for deeper research, enhancing our understanding of how humor is constructed and perceived by both artificial intelligence and humans. As we proceed, these findings will not only inform our approach to developing smarter AI, but also enrich our appreciation of the complexity of human wit. In our annotation analysis, we focused on evaluating the funniness and originality of the humor content in both AI-generated and human-generated texts. Let's discuss the funniness ratings. Interestingly, human-generated humor is more frequently rated as not at all funny. In the somewhat funny category, AI and human humor are comparable, with humans just slightly ahead. This suggests that both AI and people have a similar ability to create content that's mildly amusing. Moving to moderately funny humor, the occurrence is similar for both AI and humans. It is here that both seem to be producing content that is amusing enough to potentially make us laugh. Now, here's where it gets interesting. AI-generated humor actually outperforms human humor in being rated very funny. This is a demonstration of AI's growing ability to craft content that's quite entertaining. However, being rated hilarious is very rare for both AI and humans. It's a clear indicator of the challenge in creating content that universally makes people laugh. In summary, AI shows real promise in generating humor, standing out particularly at the very funny level. Yet there is still room for improvement, especially when it comes to achieving that hilarious rating. Let's move on to the key findings and our conclusion. Our study reveals a couple of key insights. Let's begin by considering the nature of AI-generated jokes. Typically, these are more neutral and get straight to the point. while humans tend to infuse their humor with a variety of emotions and a touch of complexity. On the topic of funniness and originality, AI has its moments where it can actually outdo humans in delivering a punchline. However, it often falls short in being original. This pattern suggests that AI might be borrowing from a playbook of existing joke structures rather than creating something new. As for the building blocks of language, backgrounds and parts of speech, AI and humans are on the same page. Both use similar structures, which shows that AI is quite adept at learning the grammar of humor from human examples. However, when it comes to the emotional depth, AI's humor doesn't quite resonate as deeply as that of humans. This points out toward an exciting frontier for future development, where AI might learn to not just tell jokes, but to tell them with the kind of emotional nuance that really makes us feel. In summary, while AI can mimic the structure of human humor to some extent and even match in funniness at times, it still has a way to go in terms of originality and emotional connection. Our findings underscore the importance of enhancing AI's capabilities in creating humor that not only makes us laugh, but also connects with us on an emotional level. The aim is to develop AI that can craft jokes that are not just clever, but also feel genuine and heartfelt. Additionally, we see potential in teaching AI to use strategies that humans naturally employ when creating humor. This could mean understanding cultural nuances or delivering a punchline with just the right timing. However, our work is not without its limitations. We must acknowledge the subjective nature of humor. What one person finds hilarious, another might not even smile at. Therefore, the study would have benefited from having more than 2 annotators. Moreover, our dataset has its bounds. It may not fully represent the vast diversity of humor styles across different cultures and contexts. As we move forward, we aim to address these limitations by broadening our dataset and refining our understanding of humor's subjective qualities. A couple of references, and thank you very much for your attention.